Hello, everybody. I'm Don. I'm doing a presentation on gateways. There's a lot of different challenges that we have in cybersecurity. A lot of times, in fact, the very first time that I worked with Car for Car, I'll pronounce it that way. The very first time he showed me how to fool the vehicle so that the radio thought it was in park and I could watch a video while I'm driving. Okay, so that was literally my first exposure to faking the car out. But a lot of times we have to change a signal or a PDU, a collection of signals. We want to block something. We want to override something. We want to change something in a frame. Maybe you want to add something, but it can only go to the target ECU. I don't want it to be sent to any other ECU. We need to convert something to some format, some protocol. For instance, maybe I have CAN-FD or I have LIN, but I really have a device that can only do CAN 2.0 or classical CAN, or maybe I'm doing CCP or XCP, and I need to actually convert that out to some periodic CAN signal because some device that I have can't deal with the CCP or XCP data. Sometimes we need to limit the number of frames that are going to some device. Okay, so for instance, a good example is you might have 16 ECUs in a battery pack, for instance. And all those 16 ECUs might be doing some work. You might want to talk to those, but there's so much traffic already that if you send that traffic out and you're also sending it to all the other ECUs connected to it and monitoring those, then you might actually cause the bus to crash. So being able to either limit the traffic down to a manageable amount or to consolidate specific frames or even take different signals, which I'll demonstrate at the end, take different signals and consolidate them into a single frame of traffic is something that you want to do. Okay. And one thing that is just starting to hit the scene right now is protected PDUs. Protected PDUs are basically when we're sending a PDU or a collection of signals, and it's sent with essentially a protection value, a MAC, as well as a freshness value. And so changing that data, if we were to say try to tweak it, means that the target ECU is essentially going to ignore the frame because the MAC is created with the PDU or collection of signals as well as the freshness value. So changing the signal changes what the MAC should be. And so if we wanted to make a change in that, it's going to be a lot tougher, but we'll get to that. Okay. So the solution, I've heard it called many names. Okay, I've heard it called a gateway, a translator, a converter, a bypass. But essentially, all these devices will ingest some traffic from some network, and then it will put the traffic out on the other side in some certain format. Sometimes it simply bypasses. It's a total pass through both directions. It does not affect the data, but you can see what's coming in and going out. Just to examine it and do further analysis. But I will call it a gateway. So essentially, gateway is really that conduit of information going from one vehicle network to another. So I've done several of these. I used to do them all manually, programming them in the devices that my company happens to sell. But doing CAN to CAN or CAN to LIN, CAN to LIN, you essentially see that all the time because there's always a CAN ECU that operates as the LIN master. CAN to Ethernet or Ethernet to Ethernet, like switches that you see inside of vehicles. Many vehicles now have a central gateway or a common gateway, several different names for it, but essentially all the traffic goes to it and gets routed out to minimize repeating traffic on multiple buses and to segment the vehicle out. That's not really the central gateways or common gateways are not the subject of what I'm talking about today. That's really kind of for another day to talk about defeating those, that kind of thing. So how do you make the gateway? Well, back when I was a little younger, I used to code it myself. So when you do that, one of the biggest problems with it is it's easy for somebody like me to get confused. What's being received versus what's being transmitted. You have to keep in mind, if I'm going from one bus to another, one thing that's being received on one side is being transmitted on the other. I have to be able to make sure I don't accidentally retransmit the thing I transmitted on the other side back again, causing essentially a big loop, right? So coding it yourself can be a problem because of the amount of time it takes. It can also be a problem because of the performance of the device. Okay, not everybody can afford a hill and be able to send out traffic really fast and have super high performance as though you are in a vehicle network. So another way to do this is a rapid development tool, and that's what I'm going to show today. But the tools themselves are really a sidelight. Okay, the idea is to show certain examples of the things that you might need a gateway or things that are possible. Maybe a couple of things you haven't thought of yet. But I plan on doing a demonstration of those all today. So, and I already talked about this part, but essentially, these are the function blocks that are inside of Intrepid's Vehicle Spy software. And I used to write these, step by step and write all the code that goes around it to do a gateway. Generally, it would take me hours and then some time to troubleshoot to get any gateway right. So one thing that our customers often demanded was they did not want to write anything, which is kind of a tall order. How do you make some type of interface where you can create gateways and it automatically generate the code? Well, after several years of dreaming, that actually is done inside of Vehicle Spy. There are other tools out there, of course, some that are actually, you can actually run embedded C code in. Some of these tools actually you can run embedded C code as well. But most of the tools that Intrepid makes can actually run gateways or simulate ECUs for that matter. And many of them can actually run C code as well as running the function blocks that I just showed. So, the idea is essentially we have a relatively new view inside of Vehicle Spy called the Gateway Builder. And the Gateway Builder essentially creates those function blocks for you, and on occasion will also create embedded C code depending on the task that you're doing. So it's really pretty straightforward. I'm not going to tell you that I love the interface, but it's not bad. It takes a little bit of getting used to. But it's really our first attempt at the GUI. But it does definitely do a lot of things. So essentially, you start out by loading the databases that you create, or maybe some that you already have. And you essentially drag and drop the networks or the messages or the signals from the input side to the output side. And you can create multiple layers of these so that you can do things like, I'm going to pass this one entire frame as it is every time. Or I might also want to pass a single signal and then lock down what the other values are. But in any case, once you create it, then you can click on a button that downloads that programming into the standalone hardware. So to give you an example of what you can potentially do with this, I'm going to pull up this little guy here because it actually is connected up to this right here. So what's happening here is that on my PC, I've got this NeoVi Fire 2. It's connected up to this NeoECU, the NeoECU 12 here, which is essentially like a little NeoECU simulator. It basically is pretty straightforward. It's really very cheap. What we're doing here is that we're sending CAN out, dual wire CAN out. It goes into the NeoECU 12. From the NeoECU 12, it's actually coming out as LIN, and that comes out over here, and that connects up to this guy, cluster. So, and I can, of course, adjust that cluster because there's actually a gateway going on. See that it gets a little bit dimmer, fuel level go up and down. Right there, you see it. RPMs up to like 6 grand. Vehicle speed, let's go up to like 260. Got it pegged, but if you look up there, you'll see the speeds up there like 248. That's kind of cool. So this is actually Gateway that was programmed inside of that Neo ECU 12. And the Fire 2 that I showed is really just a way of showing it, okay? But that's just a quick example of something you could do. You can use it for like a prototype, use it for testing. You see it a lot in industry or in automotive design and validation as part of a test bench. But it can be pretty useful on the hacker realm, because now I can take something and say, well, I don't like that it's sending out this signal here. I can change it to something on the other side, right? Change it to what I want. Change it to something that might give me a result and give me more clues as to what to do. So what I'm going to do here is essentially give you a quick view, a rundown of the Gateway Builder view, but I'm also going to pull up several different demos to show how this can work for you. So essentially on the left side here, you'll see it says inputs. What this means is we've loaded in databases, and in this case, it's loaded up to HSCAN. This might be, in our future products, it's called CAN1, so the first CAN channel. And so the database is loaded up over here, and that would be the input side, where it says input network. On the output network, I've got MSCAN in this case, and another set of databases here. So essentially, you have to have a database on the input side and on the output side, so that the Gateway Builder knows the structure of the messages, the signals, PDUs on both sides, and then you can then tell it, pull this signal in, change its value, put it into this other signal on the other side. Okay, so in that case, with the exception of gatewaying the entire network, we have to have a full database of some sort, even if that's something you created. And these databases are actually totally fictitious. Some I created, over 10 years ago now. I use them for training all the time. So now I'm going to go through a number of demos and explain what's going on. Basically, here on my desk, I've got the same setup you see there on the slides. And basically, I've got two fires that are tied together with a test board. So essentially, there's a termination in between, somewhere that powers up the whole setup. I'm going to plug that guy in like you see on the slide. Now, let's do some demos. So the first demo I'm going to show you is essentially a bidirectional gateway. Really, really simple. Doesn't get simpler than this. So what I can do is actually just rip this thing apart and put it back together again real quick, just to show you what it's actually doing. And in fact, well, yeah, this should be fine. Let's do this. So one thing you can do is you start out with an input network. And this one I'll choose as HSCAN. And this is one of the few that does not need the database at all, but I have the databases loaded. So input side, where I'm going to start out, HSCAN. On the output side, I change it to MSCAN. And if I simply just push the button that says Gateway Entire Network, click that, and now all the messages that are on that one network will be sent across to the other network. Okay. Now, if I want the messages that are on the other side, on MSCAN, to come across and come back to the HSCAN network, I can do that too. So I need to select the MSCAN on the input side and HSCAN on the output side. And again, click on Gateway Entire Network. And that basically is both sides of the network. So what I'm going to do is actually plug in a NeoVi that actually you'll see it says HS plus MSCAN on it. That's because it's actually sending traffic out on both those networks. And I'll show you that once I fire this guy up. And I'll actually show you all the traffic. So you'll see here it says FC and there's another one FC. This wheel speeds is actually being pulled in on HSCAN and transmitted back out on MSCAN. And if you go through here a little bit farther, you'll find there are some that are on MSCAN, like the STAT1 right here, and it's being retransmitted on HSCAN. So that's pretty quick. I basically ripped apart the gateway, rebuilt it again inside a vehicle spy like that. Not bad. So what's the use of this besides just showing off? Well, the thing is, I can tell by this traffic here. Oh, of course, my mouse decided to die. Awesome. Not awesome. Wake up. Hello. There we go. Sorry about that. So I'll just type in the filter here. So I can tell that this message is coming out of the subject or the target ECU, the one that has the simulation inside. It's not plugged into my computer because I'm receiving it on my test tool and I'm retransmitting it on the other side. So if I were to have something like this that were actually connected between an ECU and the rest of the vehicle, I could potentially figure out all the things it transmits. Probably a lot quicker, though, just to disconnect the ECU, see what disappears. You may get some other things that do appear. But this is something where you can actually connect up, still keep everything running. The timing is actually very, very good. Very, very good. And you could then start to play with it and build a gateway, take messages away, keep all the other messages coming along. And I'll show you all that here in a moment. So now here's another one. These will all get a little more useful as we go along, promise. So basically, what might be a little bit more useful is I grab onto a single frame, a single PDU, a set of signals, and I want to say transmit that on another bus, and I might do something else with it, okay? So I'll go online with this one just to show what's going on here. And you'll see there's only one being transmitted. It's just that MSCAN, and that actually is being retransmitted from this data 7. It's not being changed. It's just being transmitted at the same rate. So in the gateway builder to build this, let me go offline for a second. It's really pretty easy. I can hit this delete all button that gets rid of all the stuff. And all I've got to really do is go over here and say, well, I want to grab this one frame. So this right here at the top of the tree, I can just drag it over, drop it in, and then off I go. It's already going to forward that message. So you see here on the input for the message, and it's going to automatically show up on the other side. I don't have to tell it what message to put it into at this point. When I say forward, it will take the message as it is and just forward it across. It's not going to play with it yet. It will be like that soon. So and if I go online, I'll just start firing up again, just like it did before. In time, there we go. So now we'll do something a little more fun. Oh. So say that I wanted to do something a little more exotic. I wanted to choose when and if I retransmit based on some data. Now, this data could be data that's in another frame. I'm going to go online and I'll show you what's really going on here. It may not be clear right away, but it will be once I tell you what to watch for. So just like before, we're retransmitting data 7. But basically, we're going to wait until that target speed goes below 10. Once it goes below 10, it will stop retransmitting. Okay. So to show you how that works, we'll come back to it. You can actually see that happen. Essentially, instead of just Instead of just forwarding the message, which is what we did in the last example, we put a condition on it over here. And so that condition is actually built into this expression editor. So target speed is greater than 10. And then in a little bit of time passes, and it went way up again. I should have let it run. But basically, that's another alternative that you could do that. You can do things where you're not using the data from the thing that you're retransmitting. So this could be based on another message, something from another network. You really could do whatever you want. Okay. And eventually, you'll see that guy go down. I'll let that guy run for a while I pull up the next one. And eventually, you'll see this guy is going to stop transmitting because that guy right there will actually start to fade away. You'll see that highlighting will fade away. In the meantime, I'm going to pull up another one because this is probably something that I see requested a lot. Okay. This guy's just about, over here, is just about to go away. But basically, I might want to grab something and then just change the arbitration ID. Okay, change the ID. And by the way, this one just finally went away. That's why it stopped at 292. It's no longer transmitting. So it just jumped up again, and now it's transmitting again. So in this one, set up in a similar way. However, if we're going to remap it, then what we need to do is to choose something a bit different down here for the option. We cannot just forward it. We're actually going to what we call map it to another message. So over here, I've got, in this case, it's data 7, and it was pulled over here. I will end up deleting the second one here in a second. I'm just going to rebuild that first one, get rid of the second one, and then run this demonstration. But essentially, if I want to map it, now it starts looking for a message saying select a message. So over here, I have to find a message that I'm going to map it to. And in this case, we've actually made a transmit message that I can grab. And since I'm grabbing the entire frame, data 7 here, so that's got all the signals in it, right? I'm going to grab this entire frame and drag it down and drop it right in here. Okay. And that's how I created that first one. So I'm going to go online, and then you'll see that this is actually duplicated. So I've got, let's see, I believe it's, oh, yeah, there we go. It's 123. 711, I believe. Let's see if I got them right. Yeah, looks like they're, they're right next to each other there. So that's another tweak I can do. So now I'm getting a little more sophisticated, a little more realistic to things that you might want to do. Okay. This is something that I've had people ask me many times to do, just in testing validation, also in, for cybersecurity. They want to change something, hook it up to some other device, record it, etc. All right, next one is I have it in CAN and it needs to go to CAN-FD. So again, the same idea, you're dragging over from your message, your input, and then on the output, you're picking another frame for it to go to. In this case, it's simply a classical CAN frame, this data 7, and we created a CAN-FD frame on the other side. Just a second here. I'm trying to see because my eyes are terrible. So essentially, you'll see that it's got 3 separate signals in here. You can ignore those other things. Those are actually just properties of that CAN data 7. And you'll also see that they have the same exact names over here as well. So those will automatically get mapped over, but the size of this frame is different. You'll see that here in just a moment. The warning it's talking about is the length of bytes is 20. The warning on this little warning flashing light, but this one's 8. So this one's actually 20 bytes just to show it's CAN-FD. It'll still go online though. So I know I'm throwing these up really quick, but the fact is, I haven't used this probably in a year and a half, and I actually went through all these and did this all within the last 2 hours and troubleshot everything and got it running. So even if you were totally new to Vehicle Spy and the Gateway Builder, then you could get this done, like start at 10 o'clock in the morning and be done by lunch. Probably have everything troubleshot and ready to go easily. Most likely you will have it done in a few minutes if it's a simpler one. So you can see this one right here is actually standard CAN. You can tell that because in this view, you'll see there's FDF and the VRS ESI. Those are different switches for CAN FD. They are not present in all the other data because that's all standard CAN or classical CAN. But you do see that those values are in this frame. And of course, it's 20 bytes, so that's kind of a dead giveaway. All right. All right. Now we're getting to more and more fun. So in this next demonstration, I'm basically grabbing a certain signal and tweaking that signal. Okay, so let me show you what this is doing this time. In this case, what we've done is not grabbed the whole message or frame. I've actually grabbed one signal. So in this case, it says LF wheel speed. So left front wheel speed, and we just drag that in, and now we've got a signal. So if we do a single signal, then it will be interesting to see what really happens when we do this as a gateway. Because of course, it's not like you can get one signal and just forget all the rest of the data bytes in your CAN frame, right? So in this case, what we're doing is we're actually still forwarding it just like we had been forwarding entire CAN frames. But we are taking this one signal and we are changing it by using this expression checkbox. And in that expression, we're making it 255. So we're going to make it FF, essentially, because this is going to be 1 byte. So let's fire this up and see what happens. And time pass. There we go. Here, I'll just go ahead and get rid of that filter. You can see that everything else is still working, but you only have this one MS CAN coming across here. And this data 5 is what we actually were grabbing one signal from. So let's filter this out and see exactly what's really going on. And so in this case, this LF wheel speed, you can see, unfortunately, these are all the same value and they stay that way. But this LF wheel speed is actually byte 4. And that's why it says FF here, but it doesn't show any values from the other ones. So one question, why would it not transfer the other ones? Well, you did not tell it to do it. You only transferred that one signal. So if you want to, you can transfer the other ones. And you can change those if you want, or just transfer the existing value. So that way you can tweak right down to the byte, whatever signal you make, even if it's a single, just a single bit, you can actually tweak it in this manner. Okay. All right, I've got 2 more demos and then a few more slides, and then we're ready to roll. Okay, so now we're going to get to something a little more elaborate. So essentially what we're going to do is take a couple data bytes, and we're going to send those across. Let me go online with this one. Might have actually found a bug in our existing software in this one. Something tells me that this one was not working quite the way I wanted it to. So basically, in this one, I think this is one that actually is not working quite the way it should, because it's not actually wrong. This one is actually supposed to have a different calibration on this engineering RPM. Let me try something different. I'm going to try to reload this in. Essentially, what I would do is grab this engineering RPM, pull it up, and then choose map down here. And then the mapping would actually be to when I map it to the other signal. So that I can pull this guy in, drop him in here. Yeah, there it's now it's saying it's a warning. But it looks like we've got some error somewhere. I found some bug in this just a couple hours ago. But you can see that the scaling, originally there's no scaling. But in this case, I'm actually sending it to a signal that has a different scaling. And in this case, I could actually change the scaling on the fly as part of the gateway. So let me go online with this and we'll see if it works. I have a feeling it's not going to work. So, oh, yeah, we got a problem with that one. There's definitely a bug in there. Sorry, guys. It happens. Oh. Uh-oh. Now we got real problems. Give me a second here. I'll try to find that one. See if I can actually make this other one run, because we are almost done. Actually, you know what? That is actually the last one. Let me, oh, no, this one I want to do, definitely. This last one is actually combining the signals from different frames. So essentially, I've taken one signal from this data 6 frame, a couple from data 7, and one from steering wheel angle, and I put them all together in a separate database over here. So essentially, those are now all combined, and all 4 of these run at the same time. Let's see if we can get away with running this. I don't know if I'm going to with that other instance crashed on me, so I might get away with it. I might not. Worked. So basically what you see here is that we are actually taking the values from each of these that I've mapped. Like in this case, I think it's fuel alcohol %. So you can see that guy's the same. Target speed is mapped. I think the only thing is I should have forced this to a certain data rate. That's why it's jumping around so much. It's pulling in, it's transmitting every single time any one of them changes, and they're all out of sync. So let me jump out of this. We can kill all these instances. We've got enough. I've done enough vehicle spy for today. Get rid of all those. Woo. Holy schmoly. How many copies do I have running? About 15. So essentially, last couple slides here. This won't take long. It's like 8 more slides. We're done. So message injection. Or signal injection. Sometimes you want to just change the data in a certain can frame. And in the old school way is to simply just transmit twice as fast as the existing frame on the bus. And when you do that, essentially what happens is the ECUs that are monitoring that will essentially always see your value, see your frame, because yours is coming out twice as fast. Unless it's exactly on the money, then you're going to, that ECU will always see your values, not the actual ECU's values. So that's really pretty easy, and that's the way we've done it for many years, ever since CAN has been out there. Anytime somebody wants to play with something, force something in a certain ECU, that's great. However, the problem is we have protected PDUs. So the protected PDUs are essentially, they're part of AutoZAR's secure onboard communication. It makes the vehicle or the ECU immune to replay attacks. And you cannot override a CAN frame because the MAC value that's being transmitted and the freshness value along with it is part, the signals in the freshness value are part of the MAC. So therefore, if you change the freshness value, if you change the PDU or the signals, then you have to have a new MAC. And if that MAC doesn't jive on the other side, then no go. The ECU that receives it will ignore it. So you essentially have to have a man in the middle, okay? And that's just the beginning, okay? So if you if you are going to do this, that means you'd actually have to put security into the Neo5, okay, or into your box. And the fact is, we actually have already implemented this for some OEMs. because they have to use it to test. There is no way to do this injection testing to force a certain signal unless you can change the signal, recompute the MAC, keep the freshness value, and send that on and do it quick enough, like a hill, in order to be accepted by the ECU. And I'd love to demonstrate it, but I can't. Not that I can't do it, just that I'm not allowed to show you. But it can be done. So any questions, feel free to contact me. I'll be in the village, and I'll be at the Q&A here, I'm sure, when the video stops playing. Thanks a lot.